Hello everyone. Today we'll try to see how R square and adjusted R square are different from each other and how these two can be used for regression analysis. So for this exercise we're using the mtcars dataset from Kaggle. Let us first import the required libraries and then load our dataset. So over here the miles per gallon is our predicted variable which we'll try to predict, and I have just plotted it against the first independent variable, that is the weight. So miles per gallon against weight, miles per gallon being the y-axis and weight being the x-axis. So this is how the distribution of miles per gallon looks like against weight. So the entire exercise will be performed on trying to predict the miles per gallon itself. So over here we'll try to see how does our correlation matrix look like. How does each of the variable correspond and or relate to the miles per gallon. So over here we see miles per gallon is inversely proportional to cylinder by a factor of 0.85. So if cylinder increases by 1, miles per gallon will decrease by 0.85. So on and so forth. And this is the heat map for the corresponding same correlation matrix. So these are the various column names. Miles per gallon is a predictor variable, cylinder, displacement, horsepower, weight, cubic, and so on and so forth. So now we'll get into model building. So what we first start off with is we'll build a model on in which we'll try to predict the miles per gallon with respect to weight and horsepower. So for this we see the R squared is 0.826 and adjusted R square is 0.814. So these are different, we see, from each other. Now we'll see how they're different, like why. For that we plot our next model in which we have added one more independent variable, that is cylinder, to it. Previously it was weight and horsepower, now it's weight, horsepower and cylinder. So using these three variables we'll try to predict the miles per gallon. Now when we do so, we see both adjusted R square and R square have increased. The previous value of R squared was 0.826, now it's 0.843. And adjusted R square was 0.814, now it's 826. So there is a significant increase. So will always both of them increase simultaneously? Let's see the next example. Now we have increased the number of predictor variables by 1. That is, we have added displacement to it. The predicted variable being the same, that is miles per gallon. Now we see the value of adjusted R square has decreased. Previously it was 0.8263, now is 0.8262. So it has decreased. Whereas R square has increased. Previously it was 8.8431, now it's 0.8486. So again, there's a significant increase. But why so? So adjusted R square means how much of the variations in the data set the model is able to capture. So if we increase the number of predictor variables, the model becomes more complex and is able to understand the variations better. So the value of R squared will always increase if we increase the number of variables. But what is adjusted R squared? Adjusted R squared gives us the importance, the statistical importance of a particular added variable. So here we see when we increase the number of variables by 1, that is when we add displacement to my predictor variables, the value of adjusted R square decreases. That means the variable displacement does not improve the performance of my model or does not add to my model the way it was expected to have. So, if the value of adjusted R square decreases, it means the new variable that we have added is not significant enough for our model. It will increase the complexity, yes, but will not statistically improve my performance. So, adjusted R square can be used as a method of selecting the features that are to be included in our model. What, so what happens if adjusted R square increases? For example, over here, when we added cylinder to uh, after horsepower to our new model, we see both the R square and adjusted R square increases. Now, if the adjusted R square also increases, it means that the new variable, that is cylinder over here, is adding to my model. That is not only increasing the complexity of the model, but also it is statistically significant to my model. That is, it is helping my model perform better. So the next question arises, are all will adjusted R square increase for all variables that are correlated to the predictor variable? The answer is no. Over here we see displacement, horsepower, cylinder, and weight. And weight. All are correlate to each other, maybe negatively or positively, but they have a significant value of correlation amongst each other. So even if a variable is correlated to the predicted variable, still the value of adjusted R square might be decreasing. That is, it still might be statistically insignificant to the model even after being correlated to my predicted variable. So adjusted R square is a very important feature and we can use it for feature selection. Thank you. Hope you enjoyed it.